So I want to find dy dx for that curve. So let's take the derivative implicitly with respect to y. So the derivative, with respect to x. So the derivative with respect to x of x squared is 2x plus, and then the derivative of this with respect to x, I'm going to have to use chain rule. So I have to do cosine and leave the inside alone times the derivative of the inside, which is dy dx, equals, and again I'm going to have to do chain rule here, so I get 2y to the first dy dx plus 0. And so now I can solve this for dy dx. So the two terms that have dy dx in them are this term and this term. So I'm going to get those on the same side and move that 2x to the other side. So I'll have cosine y dy dx minus 2y dy dx equals negative 2x. And now I can just simply factor out that dy dx. And divide by that leftover bit. Okay, and then now I want to, I think that's it. So here I see a 6-foot tall man is walking away from a lamppost, which is 11 feet tall. X is the man's distance from the lamppost, and y is the length of the man's shadow. Determine how fast the man is walking if the length of his shadow is increasing at a rate of 12 feet per second. So the 12 feet per second is the length at which his shadow is increasing. So that is dy dt is equal to 12 feet per second. And the question is asking how fast he is walking. In other words, how fast x is changing his distance away from the lamppost. So we want to find dx dt when, let's see, we want dx dt, and we know that his height is always 6, and we know that the lamppost is always 11 feet tall. So those are some things we know as well. Okay, so if that's what we want, we first need to find a relationship between x and y, and then we can take the derivative of that implicitly with respect to t, and then that dx dt and dy dt will show up. So what relationship can we get between x and y? Well, the first thing you have to see here is you have to see these similar triangles. So this triangle and then this big triangle. Okay. So if you see those similar triangles, we can see that we can write down a relationship between x and y. So we just set up a proportion. So we could say the height of the big triangle over the base of the big triangle is equal to the height of the man over the base of the little triangle. And so we get that. And if we multiply both sides by those denominators, we'll end up with 11y is equal to 6 times x plus y. And so now I can distribute that 6, 11y is equal to 6x plus 6y. And then I can take the derivative implicitly with respect to t. Okay, and so if I do that, I get 11 dy dx is equal to, dy dt, excuse me, is equal to 6 dx dt plus 6 dy dt. And then I know a value for dy dt. I know that dy dt is 12, so I'll just plug that in. And so then I can solve that for dx dt. And then the units for that, again, x is measured in feet. So x is his distance from the lamppost in feet. So the units of this are going to be feet per, and then what are the units of t? T is measured in seconds because I know dy dt is in feet per second. So this is also in feet per second. And so that's the man's speed. That's the change in x over time. So that's the man's speed. So let's write a sentence. The man is walking at a rate of 10 feet per second.